If XML were just made up of simple types, then our job would be really easy. But of course, you can define complex tag structures in XML, and we need a way in Schema to enforce constraints on those. Complex elements are elements that don't just contain basic content like strings or numbers. They can contain other tags or have attributes. So there's two ways to do this. The easy way is to use the anyType for the type attribute in the element tag. So if you define an element and inside the type attribute you specify anyType, it pretty much means that the content of the element is not restricted in any way. However, you can also use the complex tag type in the definition, and this is the counterpoint to the previous examples in this chapter where we were using the simple type tag. So let's look at some examples. So how would you declare an empty element using Schema? So we have here an empty element, and the way that this works is using the element tag. So to declare this element as being empty, you simply put an empty complex type tag inside the element declaration. So we're leaving the content model for this element empty, and that's all there is to it. That's how you declare an empty element. It's a little bit more verbose than DTDs, but this is how Schema works. Like DTDs, however, you can also declare elements that have mixed content. In this case, I'm declaring an element named title, and I want its contents to be mixed, which means it can contain both character data and other elements. So recall earlier from the DTD chapter, it is possible to declare elements that contain both character data and elements, and Schema is no different. In this case, I'm using the complex type tag, and to declare that it has mixed content, all I need to do is put that mixed equals true attribute on the complex type. And then inside the complex type, I can use the sequence or choice or any other Schema declaration tag for how the content model is going to look. Now, in this case, it's a sequence. And we're defining a sequence of subtitle and author tags inside the title tag. And since I didn't use the min occurs or max occurs attributes, it's assumed that only one subtitle and one author are going to be allowed inside the title element. You can also declare elements that have element content inside them. And again, this is very similar to DTDs. The sequence specifier essentially means that the child elements have to appear in the order in which they're declared. And that's again very similar to the way DTD works with commas in the element declaration list. So here in this example, I've got an element I'm declaring, and its name is address. And inside the address element, I'm declaring that it's a complex type and that the address element is made of a sequence of other elements. So inside the sequence declaration, I've got 4 elements: num, street, city, and state, and they have to appear in that order. The next option is the choice element. Here I've got an element I'm declaring named vehicle, and it's a complex type. And inside the complex type, I'm specifying that the elements that can appear inside the vehicle definition are one of the following list. So in this declaration, a vehicle can be a car, bus, van, or truck, but only one of these can exist. And then finally, I can use a declaration that says that certain elements can appear in any order inside of the given element. So for example, here I'm defining an element named capital city, and it's a complex type. I'm going to use the XSD all declaration. So what the all declaration essentially means is that the elements that are declared inside the all tag can appear in any order. So my capital city element is going to have tags named name, state, and pop for population, and they don't need to appear in that specific order. They can appear in any order. Okay, that's pretty much it for elements, and in a separate video, we'll take a look at declaring attributes using Schema. Now that we've looked at declaring simple and complex elements, let's take a look at how to declare attributes. Like elements, attributes are declared using their own element in Schema, and that happens to be called, surprise, the attribute tag. Attributes, unlike elements, are always simple types, so that makes things a little easier. There are no complex types for attributes in Schema, and that's because attributes can't be complex types in XML anyway. Any of the simple types that we saw in the earlier tables that I showed can be used for elements, can also be used for attributes. So recall from those tables, We had values like string and Boolean and date and URI and so on. And you can use any of those types in attribute declarations. So consider a simple example like this one. This tag declares an attribute named age and its type as an integer. In addition to the name and the type, you can indicate whether an attribute is optional via the use specifier. Use can have one of three values. It can be optional, in which case the attribute can either be included or omitted. It can be required, which means the attribute has to be there, otherwise it's an error. Or it can be prohibited, which means that the attribute can explicitly not be used in the XML data. In addition, you can specify that attributes have a default value. As you can see, I've done here in the last example where the default value is 20 for the age attribute. We can add attributes to a variety of element types. So let's take a look at adding an attribute to an element that only has character data content. So recall from the earlier chapter where we talked about declaring elements. So in this case, I've got an element called name. And inside the declaration for the name element, I've got a complex type. And I'm using mixed equals true. Remember, mixed means that the element can have mixed content. However, since I'm not declaring any elements inside the complex type, that means that the content for this element can only be character data. And then I declare the attribute named age and specify that it is an integer. All right, let's look at adding attributes to an element that has an empty content model. Now, in this case, it's pretty much the same as the previous one, only I've just removed the mixed equals true attribute. The attribute name is source, and it's a string type. But since I've removed the mix equals true attribute from the complex type tag, now the element is empty. It doesn't have any content whatsoever inside of it, and it only has this one attribute. You can also add attributes to elements that have element or mixed content models. So let's see an example of that. Here I have an element named car. Inside this declaration for the car, I've got a complex type, and it's going to be a sequence. And the car element is going to have two other elements inside of it, make and model. Both of those are strings. After the sequence is where I declare the attribute, and that attribute here is named year, and its type is a Gregorian calendar year specification. Now, this is an important point. The attribute declaration has to go after the element definitions inside your type. If you remember back to the elements part of the chapter, we talked about how to declare elements that have certain types of sequences or choices inside them. Attribute definitions have to go after those tags. That's pretty much it for declaring attributes. And as you can see, it's much less involved than declaring element content. All right, let's take what we've learned about complex elements and attributes and build a schema definition to represent XML data that defines a set of products. So here in Start folder for Chapter 9, let's open up the product list XML file. And you can see that there's a root element named product list. And inside that tag, we have a series of product tags, each of which has a name and a price. The name tag also has an attribute that indicates whether the item is in stock, and that is a Boolean value of either true or false. So let's go ahead and create the schema file for this XML. Let's open up productlist.xsd. All right. The first thing we need to do is define the root element, which is called product list. So let's add that. So I'll add an XSD element definition, and it's going to be called product list. And we can see that product list is going to be a complex type because it has these other tags in it, right? It's not simple. It's got all these other tags inside. So that means I have to make it a complex type. And we're going to make it a sequence. Inside the product tags, there's going to be names and prices. We're going to have a sequence of products and then name and price inside each of those. So inside the complex type, let's define the product tag that forms the sequence. And we know that will also be complex, and we'll make it unbounded so there can be as many of those products as we need. So I'll create an XSD element. Oh, whoops. We need to make a sequence. and then XSD element. So we're going to have a sequence of element types, and the element will be named product. All right. And we're going to make the max occurs equals unbounded, so we can have as many of those as we need. And then inside that, we're going to make this a complex type. So now we need to define the content of the product tag, which is going to be a name and a price. We have a couple of options here. I'm going to use the all declaration so that the name and price tags can appear in any order. So that's going to be XSD all. And then we just need to define the name and price tags themselves. So let's do the name tag first. That's going to be an element. And its name is going to be equal to name. And it's also going to be a mixed content element, which means it's going to be a complex type. So that's going to be XSD complex type. And we're going to have mixed equals true. So now there are no other child tags. We can just declare the in stock attribute. So I'll add the attribute to this. The name is going to be in stock. And the type will be Boolean. All right. Now let's define the price element, which is going to be a simple type. So that's going to be an element. Its name is going to be price. And that is going to be a simple type. Now, we could just define this element to have string content and be done with it. But I want to get a little fancy here and restrict the content to a number that looks like a price, which is a series of digits followed by a period, followed by 1 or 2 digits. So to do that, I'm going to use the restriction specifier to define the rule using a regular expression pattern. Now, I don't expect you to be an expert in regular expressions. I just want to show you how to do this. So what I'm going to do is create an XSD restriction. And the base for the restriction is going to be a string. And the restriction is going to be a pattern. And the value of the pattern is going to be the regular expression. So \d means a digit. And then the plus character means a digit followed by a period, followed by, so plus means 1 or more digits, and then a period, because it's going to be a US-based price. It could be a comma if it's European. And then another set of digits, and it's either going to be 1 or 2 digits. All right, so let's go ahead and try this out. What we need to do now is associate the XSD file with our XML. So let's save this. And then on the product list, I'm going to put my XML namespace and the XSI, which is the schema interface or the schema instance, is going to be www. Okay, that's that. And then I'm going to have the schema instance namespace, and the no namespace schema location is going to be product list.xsd. All right, let's save that. Okay, let's go ahead and try some changes to see if the validation is working. So I'm going to change in stock to be something other than a Boolean. And sure enough, that's an error. We can see it's got to be either true or false. Okay, so let's put that back to true. If I try to add text to the product element, oh, that's a problem, right? Because it can't be a mixed content. It's got to be name and prices. That's good. If I try to make the price something other than a number of this format, like if I put a comma in here, we can see that that's an error. If I try to put some characters in here, that's also an error. Okay, that's working pretty well. So you can see that by using a schema file of almost not even quite 30 lines, right? We've created a simple way to catch potential problems with our XML code. All right, you know what time it is. It's programming challenge time. We are going to build an XML schema file that validates our business card content. And this is going to be very similar to the DTD challenge in that your schema will have to ensure that the XML content follows certain rules. So the business card element can only contain name, phone, and email elements in that order. The name element must be a string, and it can only be one, and it's required. There has to be at least one phone element, and it has to have a type attribute whose value is limited to mobile, home, or work. There's no upper limit on the number of phone elements. The email element is optional, but there can only be one if there is one, and it has to be a string type. All right, so that's it. This is the challenge. Take what you've learned from this chapter, build your XML schema, test it out in VS Code on the business card, and I will be back to discuss my solution. All right, let's take a look at my solution to the programming challenge. So remember, we had to build a schema to validate our business card. So I put that in my businesscard.xsd file. So let's look at the schema definition. So first is the element definition for the business card. So inside my schema, I first define the business card element, and that's pretty straightforward. It's a complex type because obviously it contains other elements. And one of the rules we had to follow was that the name, phone, and email tags had to appear in that order. So I used a sequence tag to enforce that. Next come the definitions for the elements that can be in the business card. So the name tag was a simple element because it just contains string content. And you can see that I've got that definition right here. So one line for name, and I was pretty much done. The phone element is a little bit more complex. So here I have my definition for the phone tag. And note that one of the rules was there's no upper limit on the number of phones. So I've got my phone definition. It has a mixed content type. And so it's got text content inside the element as well as other information. So I've got my attribute definition, which is the type attribute, and its use is required because one of the rules was there has to be a type that specifies either mobile, work, or home. And we saw how to do that in the chapter. We use a restriction tag to define the restrictions. And then I used the enumeration tag to define that the attribute has to be either mobile, work, or home. So that satisfies that rule. So we've got at least one phone, unbounded, it has a type attribute, it's got mixed content, and the type has to be one of these three. And then finally, there's the email tag, which is also a string type. And the min occurs is set to 0, which means it's optional. But if you do have one, then the max occurs is 1. Now, you could have just made this one fairly simple and restricted it to being a string like I did for the name tag. So if you did that, then that's great. You achieved the challenge. I decided to go a little bit further and use the restriction tag along with a pattern to enforce that this has to be a valid email. And I just looked up an email regular expression on the web. I didn't expect you to do that. If you did, though, then nice job in getting the extra credit, but it wasn't required. So if you just made it a simple type with a string, then that's great. Congratulations. So let's go ahead and make sure that this is working. Let's open the XML back up and let's try taking out the name tag. All right, well, that causes a problem, right? Because now we can see, hey, element phone is invalid, says one of the following is expected. So name is missing. Name's got to come first. Let's fix that. All right, let's make one of these attributes something else. We can see that that's a problem. Okay, so we can undo that. Let's take out all the phone tags. Oh, that's a problem, right? Because now there has to be at least a phone in there. All right. Let's take out the email tag. Okay, well, that's fine because it's optional. But let's make it something that doesn't match this pattern. You know what? Let's just take the @ symbol out. Oh, now there's a problem. And the problem is it no longer matches the pattern for an email address. And again, if you didn't do that, that's fine. I just want to make sure that my restriction works. But that's pretty much it. So using what we've learned in the chapter, we are now building business card data, and it is being validated by our schema to help keep errors from creeping into our data set.